Hello, welcome back to Chapter 2, Section 8, Solving Absolute Value Equations and Inequalities. In this video and the next video, we're going to be taking what we just did, solving equations, and we're going to take that information, but now we're going to solve inequalities, where we have a less than or a greater than. And for our purposes, if you also have a or equal to, everything else is going to work the same way. We just include that number. If we don't have that part, we don't include the number, and we'll test that. We'll show that when we graph it. All right, but that's why this shows less than, that shows greater than. In this video, we're going to be talking about disjunctions, and disjunctions are going to use the word or. So this right here is a disjunction, and all of the problems that I'm going to show you are going to start out with the absolute value part on the left side. There might be a couple on the homework. I should check to see if it switches it around. I don't think so though. The absolute value part is going to be on the left side, and we're going to use greater than. So if I have the absolute value of something is greater than some number, then it's going to be a disjunction, and I'm going to split it using the word or. Now here are the steps. First, we're going to isolate the absolute value expression. Again, this is the part where most students make a mistake. Don't forget to isolate it first. Then you're going to split it into a compound inequality. Since we're doing disjunctions in this video, we're always going to use the word or. In the next video, we're going to have absolute value of something is less than A, and that's going to use the word and. That'll be a conjunction. But we're going to save those problems for the next video. And then you're going to solve and graph. All right? Sounds pretty easy. Let's get started. So again, and I'm going to show you the other two. I want you to look at all four of them together. I'll get to this paper in a second. All of these are going to be disjunctions using the word or. All right? Absolute value greater than a number. Absolute value is on the left. I have to isolate, but it's still greater than a number. Absolute value greater than something. Absolute value, isolate, I'll have to isolate here, is greater than. All of them have the absolute value part expression on the left, and they're all greater than some number. Okay? I'll get to these two problems in just a moment. This one's already isolated. So I'm good. I can split it. And I'm going to go back to this. Now check out what happens, right? This is the pattern I'm going to use. If I have the absolute value of something and it's greater than a number, so I have the absolute value of something greater than a number, I'm going to cover this up. Well, one thing you can do is you can just drop the absolute value bars and say, well, the thing that's inside the absolute value has to be greater than that number. That's usually pretty easy. But the hard one is this. That number is also less than the opposite of whatever that number is. And one way to explain that, I guess I should do this before we do the video, or sorry, do the problem. If I had something easy, absolute value of x is greater than 3. So what could these x's be? Well, one thing, like I just said, I could have any number that's greater than 3. So 4, 5, 6, the absolute value of those are 4, 5, 6, and those are all greater than 3. That's okay. Most people understand that. The hard part is understanding what happens on the other side. I could also have x is less than the opposite of 3. Now think about it. What numbers are less than negative 3? And there's a whole bunch of them with decimals and everything like that, but I'll just pick one, like negative 7. The absolute value of negative 7 is positive 7, and positive 7 is greater than 3. So the two things I'm going to do, I'm going to leave it alone with dropping the absolute value bars, and the other thing I'm going to do is I'm going to drop the absolute value bars and switch the sign of the direction that the inequality is going, and switch from positive to negative. All right? And again, rewind that and listen to it a couple times and ask questions if that didn't make sense. Usually that's when I pause and have you guys talk to each other with your group. Okay, so here's the two things that are going to happen. 2x plus 1 is going to be greater than 5. So I drop the absolute value bars. Whatever's inside here, if this number, whatever 2x plus 1 is, if it's greater than 5, it's going to work. All right? Well, what x is going to make that true? So I'm going to subtract 1 from both sides, get 2x is greater than 4, and I'm going to divide both sides by 2 and get x is greater than 2. So any number greater than 2 is going to make this true. So 2 times 7 is 14. 14 plus 1 is 15. The absolute value of 15 is greater than 5. That works. The other thing that I'm going to do, I'm going to write 2x plus 1. I'm going to switch the sign from greater than to less than, and I'm going to switch the 5 to negative 5. So again, subtract 1, subtract 1. I get 2x is less than negative 6 this time. Divide by 2, and I get x is less than negative 3. And because this is a disjunction, I'm going to use the word or. Draw my graph. Here's 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. X is greater than 2. Here's 2. Open circle. Draw it to the right. I'll make it a little thicker. And x is less than negative 3. Here's negative 3. Fill that circle in. Excuse me, my apologies. Make sure that one's open. I lost my place. Okay, oops. And draw it to the left. All right. So pretend that one's open. If I had done this on my whiteboard in my classroom, I would have just like smudged it out. Okay. Again, don't use Sharpies when you do your homework. Second problem. First, I have to isolate, which means I have to get the absolute value of 4x by itself. That's easy. I'm just going to subtract 16 from both sides. And I get the absolute value of 4x is greater than negative 8. So now, what's under here, I could start by saying 4x is greater than negative 8. Divide both sides by 4, and I get x is greater than negative 2. Or I could say 4x is less than positive 8. Divide both sides by 4, because remember I switched the sign and I switched the negative to a positive. And I get x is less than 2. Let's draw that graph. By the way, I'm waiting to see if anyone noticed something. We'll get to it in a second. Here's 0. So 1, 2, 3, 4. 1, 2, negative 2, 3, 4. X is greater than negative 2. This time it is an open circle, and I'm going to go this way. Since it's a disjunction, I'm going to go all the way. X is less than 2. I do an open circle here, but I've already counted that one. And I go this way. What's going on here? And remember, or means that could be true or that could be true. I don't have to have both of them true. That's a conjunction. We'll do that in the next video. Just one of them has to be true. So every number that is bigger than negative 2 goes this way. Every number that is less than positive 2 goes this way. And this means that every number solves this, because I've graphed the entire number line. Okay, now I mentioned a moment ago that I was hoping someone would notice this. Let's go back up here. The absolute value of anything has to be positive. Every positive number is greater than negative 8. So I could have totally just stopped. I didn't even have to do any of this. I did that on purpose. I could have stopped right there and said, every x works. X is going to be all real numbers. because you're using logic and you're thinking about what this actually means. The absolute value gives you a positive, and again, 0 would also work, but we'll get to that later. Every positive number is greater than negative 8. The work here that I did just goes to prove that what my thought was at the beginning is going to be true. And you may get a couple problems where you're going to see stuff like that, all right? And there's something else that's going to happen, and hopefully I got a problem like that in these videos. All right, this one's already isolated, so I'm going to do 4x minus 8 is greater than 12. Or 4x minus 8, change the sign to less than, change 12 to negative 12. Add 8 to both sides, I get 4x is greater than 20. Divide by 4, I get x is greater than 5. And by the way, I don't know if you've noticed, but like the steps that I do in this problem, it was adding 8 and dividing by 4. Those are going to be the same no matter what, because what's in here doesn't change. It's only what's out here. What you're doing those steps to is going to change. So I'm going to add 8, just like I did here, and I get 4x is less than, this time, negative 4. I'm going to divide by 4, just like I did here. I'm going to get x is less than negative 1. And again, I'm using a disjunction, so it's or. And for me to graph it, here's 0, 1, 2, 3, 4, 5, 6, 7, negative 1, negative 2, negative 3, negative 4, negative 5. So x is greater than 5, open circle, goes to the right. X is less than negative 1, open circle again, and that one goes to the left. I realize these problems that I stole from Dr. Berger, none of the 4 that I have in here has a greater than or equal to. So I'm going to modify this one just to show you what the difference is. So I'm going to change it to an or equal to. I know it's not what's in the book, but it'll be okay. I have to isolate the absolute value part first. So I'm going to subtract 36 from both sides. Actually, to be honest, I don't even think it would matter. So I get the absolute value of 3x is greater than or equal to negative 24. And just like the last problem in this one, this is going to be all real numbers. So I guess I didn't need to switch that to a greater than, because this is going to be always positive. I can't help it. And every positive number, and 0, is going to be greater than negative 24. So you can just, and if you say, well, do I have to show my work? You did. You did show your work. You recognize right away that this has to be greater than a negative number. Okay, in the next video, we're going to talk about conjunctions.